Wah! Yo, y'all having fun? Look, I'm late to my own stream. Hello, everybody. Yeah, so I am dying over that that Lego emote. Oh, I love that. And I had to mouse over it. And I'm like, what am I even looking at right now? Oy vey. Hello. We got lots of beans up in chat here. My gird. I spell a Pyrex and a thunder, and I see a pine. Hello. I'm loving the vibe y'all are bringing in here. This is glorious. Much excellence. Oh my god, little dancy little guy. That's what we talking about. Oh. Okay. I have to say something. Bye, Pyrex. This library has been kicking my ass all the way down the road, up a flight of stairs. It has been that kind of educational experience. There's the concept of like falling and hitting the ground running. I feel like I went face first into the pavement and was just dragged for a good while until I'm like, okay, all right, we're starting to get somewhere. I don't know what I'm doing. That's okay. That's never stopped me before. But at no point did I feel like I was as close to actually getting this to work than I actually was. But I found some cool stuff along the way that I am definitely here to show. So I got two examples of what I'm going to show tonight. Neither of them are Protogen shaped yet. We're going to get there. I had to first be dragged through the parking lot first of my own project before I could figure out how this was going to actually be what it is. I did start with the jazzy 8-bit music. I really like this station. It's still on. I just turned it down significantly so you can hear me. Let me see what the heck the name of the station is, because I've kind of fallen in love with this station. I used it the last time we were on. It's called Chip Tune, is the name of the station on Pretzel Rocks. If anybody else does, you know, the being live thing, whether that's live on YouTube, live on this platform, Twitch, if you don't want the little thing that pops up in chat like every 2 minutes, you pay like $60 a year. And it's fine. You get access to all this music, and they do in fact have a toggle for YouTube safe mode as well. So if you're interested, you could just do that. I have no code. I am not sponsored. I'm just telling you what I'm using because frankly it works. Poor tech. Yeah, face first. Yeah, no, the visor's still like really scuffed up on this side. Oh my god. Flaming hell and a half, and you'll get to see why, because the amount of library includes I required to make this work was way more than I anticipated. It's not a bad thing, it's just we had used the display in the 30 Days in Space franchise on this channel before, and that code looked like, okay, I could probably work with this. The answer is no, not directly anyway. Because of the way that the hardware behaves. Again, I'm gonna get into it. That's what we're here for. But I didn't know what I didn't know, and I didn't realize that this was going to be more involved than I thought it was going to be. Specifically, having to set colors on a monochrome display. I have to tell it what colors. This thing's black and white. There are no colors. It's on or off, but you have to give it the color schema or it doesn't work. Yes. So I've got all kinds of words, and we're gonna start with one of the funny examples. I also apologies. I'm not sick. I just have a fantastic case of winter air collectively melting my insides. So I apologize. I'm gonna continue to cough. I could do nothing for it. I turned down the music a little too much. Let me bump that back up a little bit. I want to be able to hear it a little bit. Oh, that's the wrong way. Maybe like a 5%. That sounds a little better. Yes, winter air melts inside, specifically inside of the toaster. I am not IPX 87 rated. Best not to toy with that. That's why we charge on a GFCI outlet. For good reason. Maybe it works differently on my broods. Hey, you don't know, neither do I. Nobody does. There's liquid cooling and then there is whatever this is. That's where we're at. Okay. Excuse my arms breaking. This sensor is going to be the next thing to get replaced. It does this ever since I got it, because this was to replace the one that like died. It's so angry. I'm getting off track. Yeah. All right. Gotta find the right scene. Set the scene with the video capture code. There we go. That's better. Okay. So before I start diving into the code, I'm going to work a little backwards. I'm going to show you what we have on the display. So currently, there are a couple of menu items here, and it's very difficult to see on the camera. I'm zoomed in pretty far there. But just to go down a line, you can see there that this is in fact functional. Now, I can also go backwards too. Now, understand this. I spent a long time to just get it so that I can interact with it with a keyboard and mouse. Apparently inputs, so the documentation claims, isn't that bad to adjust to work with controllers. And that be, yeah, better RAM cooling. I should be running better with chilled air, but yeah, no, the RAM's too expensive. It doesn't care. Getting the picture drawn on that display requires way more things in the constructor than I would have anticipated. So we're going to cover the first example, which is more quote-unquote functional than the other one I'm going to load onto the board. The other one just showcases the concept of a submenu, which I actually want to have. So that's why I want to show you both. So right now we're going to look at the sketch to the left here, this one, because the first thing you're going to see is like a bunch of stuff. We've got a lot of libraries here. To give you an idea of what this example does, this example does two things. It accepts a off time and an on time for the LED that's on board. So how much time we're going to spend turned off and how much time we're going to spend turned on. And then it does the math and then blinks the LED on the board to the interval we set using the menu. Howdy Porsche, welcome in, enjoy the lurk. This was to solely just get a pretty picture, okay? So the first thing I had to change with this, with the way that this example works. Paint. I need paint. Paint is good. Because this part's going to be incredibly relevant. We've got our screen, right? And on said screen, I want you to picture that we're going to cut the screen into sections. I'm going to do my best to get this even. It won't be, but I'm gonna try. Because there's some concepts here that even I wasn't fully understanding when we first did the 30 Days in Space, and I finally actually can explain what's actually going on here, which is stoking material. Yeah, I could do that for the first two, and then I'll just... I might do it that way. Okay, so that little display, I want you to picture that the display itself is broken into 4 smaller sections, right? When we did the 30 days in space, we noticed that the display took up an exorbitant amount of memory. And I didn't like that because I thought if I include this display into the project, this is going to take away from our ability to store and use the exterior displays that's going to go into the Protogen Head. And I'm like, I don't want that. So I'm like, how can we do this so that we're going to use less RAM? Because that's what we were sucking up, was all the available RAM on the Hero board. Now, the reason I'm using the Hero board and not the other board is that I have to make some custom cables to hook it up to the other board. But the point is that the code I'm writing on the Arduino is going to be the same code that's going to get loaded onto the production board. So I'm less worried about that, more worried about making it efficient for our problem here. Database class. Oh, you better buckle up, Buttercup. We're about to get math shaped. We're about to get math shaped because we have 2048 bytes of RAM, right? And this has nothing to do with the RAM shortage. Every time I come here, you hit me with memories from school. Memories, flashbacks, yeah, no, things happen. This is just another one. No, bytes, I say, not megabytes, bytes. 2048 bytes of RAM. With the way that the screen was set up in the 30 Days in Space franchise, we would stand up a buffer that held the entire screen's worth of combinations in one variable. The RAM class, exactly. And when you take a buffer, right? Buffer is just setting aside a chunk of RAM that we're going to use in our program. Well, the problem is that a full screen buffer for a display that is 128 by 64 is 1024 bytes in size. Automatically, that makes the buffer. That did not do what I wanted. I drew off the screen. How dare. Here. I'll make that a little bigger. Hi, Hedgie. Hedgie, I heard about the RAM. Congratulations. Okay, let's try it again. I wanted to drag that before I drew off the screen. Okay, so I already shipped it. Oh, that's exciting. Let's go. Missing the plot of a story. No. It's fine. Hedgie's building a computer. It's glorious. And you got the big guns. I heard it's a lot of RAM too, which is exciting. I hope it didn't cost an absolute fortune. It's so expensive. I should know. I'm mostly RAM. Okay, so if we have a maximum of 2048 bytes and we're automatically going to use half of it just to hold all of the data for our screen, well, that means this board is quickly going to run out of memory. So a full page buffer is not really what we need. Now, there's a benefit of using a full page, which draws sections 1, 2, 3, and 4 all together at the same time, is that the refresh rate shows a little less flickering, and that also puts us into a position where the update can be faster at the cost of RAM. Now, we want to be really efficient with our RAM usage because we want to be able to stuff as much fun into the Protogen Head as we can. So I'm like, how do I make this more efficient? Told the toaster he's gonna take it hard. No, I'm not. I am not taking Hedgie's RAM. Hedgie worked hard for that RAM. By all means, that's his. He can have it. He could behold it in chat. He has his own emote he drew. He made for me. He could use it. I say his emote. It's the emote he made for me, is what I meant to say. But that one, thank you. Yes, that thing. So to make this more efficient and more, like, really, I'd say user friendly, but frankly, none of this is user friendly. I'm user friendly, to an extent. So I think, eggs for a month. Well, hopefully they're at least cooked. Cook them first, Hedgie. That'd be fair. But if we do a partial buffer so that we don't draw everything that's going to be on the screen to one big variable, and we break it up into chunks, like I have on the screen right now, 1, 2, 3, and 4, then in memory, we have to reserve a lot less. I spy a snake. Hello. 10 seconds in, I'm confused. But Snake, I haven't even switched back street. Well, come on in. It'll make sense. Okay, once you see it, it'll make sense. Or maybe it won't. I don't know. I'm trying. To varying levels of success. Also, it's good to see you. I'm hoping you are well. I hope you're doing a lot better off than some of us are here in the land of the snow. Oh, good lord. Explain it. All right. Well, since you just popped in here, real quick, we have that display that's on the screen right there, right? It's a little fluttery, right? So to draw the pretty picture on that screen, we need in memory to draw. We have to store what we want to draw on to make the pretty picture in memory, and then send it to the display. Now, by using a smaller buffer, so don't draw the whole screen at once, which is 1024 bytes, which is half of our available RAM, we'll break it into chunks that take up 128 bytes of RAM per chunk. So what that does for us then is that this is 128 bytes, and this is 128 bytes, and so on and so forth until we get through all the sections of the screen. That saves significantly on resources. It's still the same library, it's still the same screen, but it's a lot less hardware intensive. Makes things easier. And the hardware, which frees up more resources. Now, that means that we have more resources available to us because we're not using it all at once, but that takes this down to something that's much smaller in size. Because if I come back over here for a quick second and I change the variable that dictates that, and I just verified it's not going to let me do it anymore. It's going to tell me I'm out of memory. Look at that right there. My head's in the way. It says that the sketch uses 77% of the program storage, which is fine, and 110% of the RAM, leaving a negative 212 bytes available for local variables, which means we have written something that takes up too much space. It won't work. I can't program what requires more than what we have hardware-wise. So by breaking this up into smaller chunks, I'll let this recompile so we can see the numbers. We go from being 110% of memory all the way down to 66% of dynamic memory. The storage won't change because the code itself, the storage doesn't change when it comes to the amount of RAM we're using. Yes, optimization, you better believe it. And since we want to be able to fit as much cool stuff onto the main microcontroller, this was a thing I was going to need to figure out anyway. So, to get the pretty picture, we've now broken that display into strips. and then we just draw them. And then that, in the 30 days in space, which left me very confused, which makes a lot more sense now, was the loop of first page and next page. I didn't understand what these meant when we were first working with them, but now that I understand how the buffer works on the display, so we're breaking it into smaller chunks in memory and then drawing the pretty picture, which is our menu, we need to actually cycle through all those different chunks, load them into memory, send them to the display, and then load the next chunk in memory, and then send them to the display. We don't know how many of those refreshes that will happen, especially if we're, well, technically we do know how many. It's how many chunks of the screen. I think it's 8. I think it's 8 loops, or technically, well, 8 if you're starting at 1 instead of 0. But if we don't have first page, next page, then we would only ever draw the first chunk of our display. And then we wouldn't see the rest because the rest of the screen wasn't drawn. By doing that little loop to go through all the different chunks of the display, we get the full picture. That makes a heck of a lot more sense when you understand what the library is doing, and also how on earth it looks so heavy, but by changing one number inside of the declaration of the variable, it fits significantly more and significantly better. It's a better Lego piece, and it fits into the puzzle much nicer. That's going to be this very complicated project. Start to figure 60 by 60 meter hole in the ground. Wait, this ain't Minecraft. Ah, see, but you say that, but it makes, see, but it works. It does make some flavor of sense. So, I'm working a little backwards, but I'm going to just kind of jump around. Because it makes a little bit better sense when we just jump to the point that I'm talking about. Nor here nor there. My point. We have a whole bunch going on here. For the display, we're using the U8G2 library. There is a U8G library, which was the first iteration of this, which does work with this display, but there's nicer, newer features in the G2, so that, of course, that's what I'm using. And then we need to be able to do the serial in and out and the menu. So these right here are the ones we need to build the menu that we're going to show on the display. But here's the thing I don't want you to get confused with. This library stack that we have here, menu, menu IO, serial, chain stream, and serial in, can be used with a display, but it's not required to be used with a display. As you'll notice down here, these are the written words that are on that display. I'll cycle back, I'll move it a little closer so it'll be a little easier to see on camera. I'll give you a close-up before we switch to the other one. But you could just draw a menu directly into the terminal like we have right now, right? When does that make sense? Well, say that your project doesn't have a physical display hooked up, but you need a menu to interact with it, right? Well, that could mean that you're working through a network, right? It could be a network connected device. Or maybe you're doing something that's based on text messages. Say that you have a microcontroller that has a SIM card in it, and to interact with the different menu options, it sends you a text message, and that's the quote-unquote built-out menu, and then you just text back with what you want to do, and then it draws the next menu. And then you can change values. That's the thing that's super cool about this. You can change the values of variables using that menu. You're going to get to see that. I'm super stoked for that. It's very comprehensive, which slightly changed how I want to actually display which face you're making, because the menu I want to build for the Protogen is twofold. One, I want to be able to select the face. It's going to be on the outside, of course. That's the primary reason for the tiny display. And two, if I can make it fit, I don't know if it will. I have to determine if this is going to have to be a separate component in the head. I want to see if I can build a fan menu, because I want to have fans built into the Protogen Head. And I've got my hands on some PWM controlled fans, pulse width modulation. I've talked about that significantly on this channel. It's all about controlling based on the pulses from the microcontroller. I'm not going to get into that tonight, but I just want you to know that if I can fit it into the project, it's going to be in the menu. So without getting too sidetracked in my own excitement, let me push us through the rest of this. So the LED pin on the middle of the microcontroller board, which I haven't showed you, it's off camera right now, is blinking very angrily at me because the refresh is very small, so it's blinking fairly quickly. Have you got like an end goal you're trying to reach? Is this like a menu thing? I'm struggling with what you're explaining because I don't know what the end goal is here. Yeah, okay. All right, so excellent question. Snake, what I'm in the middle of working on is I'm going to be building a full Protogen head. Inside of the Protogen head is going to be a couple of things. 2 very large LED panels, one on each side in a V formation, that's going to draw both sides of the Protogen's facial expressions. Happy, sad, content, surprised. On the inside of the Protogen head is going to be this tiny display that I just briefly showed on camera, that you as the user that's wearing the head is going to be able to visually see which face you are making on the outside of the head. The people who are looking at the Protogen head suit will not see the tiny display on the inside. It's just for you and your point of reference to know which face you're making. And then to control those expressions, we have a Wii nunchuck that I can actually yeah, I have it off camera here. Let me grab it. I can show it to you. That you'll be able to move, ideally up and down, to cycle through the different menu options. So let me grab that piece of hardware quick. Now I can't show you the displays right now because those are currently buried. Those are currently buried amongst a ton of packing material, so I can't show you that, but I can show you this. So this is going to be our controller that we have here, and we'll be able to move the joystick around up and down to be able to make our menu choices. And then we've got the buttons on the front, Z and C. That is plugged into this breakout board, which then plugs into the microcontroller. Now, the tiny display that we have here is going to get plugged into this specific port on the second one of these. We've got 2 of them. This is the one that makes the controller capture the controller data, which I have shown on a previous broadcast. The VOD is available if you're interested. It's also up on my YouTube too. Literally all of the like technical stuff does get backed up to my YouTube channel. So if you can't find it on here, go look there. It's the same name, TechHead41. But the other board, because again, I have 2 of them. This other one, right? It's identical, right? That tiny display is going to get plugged in here. And then this is a very special microcontroller with this on the back right here. This is going to get plugged into the back of the left display, the big one that's going to make the actual face. And then there's going to be a ribbon cable that's going to plug into this top connector that then will connect the 2 together. From there, we're going to make a mirror image of the whole face. We use the controller to switch between the different expressions, and this is going to be what we're going to use to make those faces. So that's the end goal. I want to make this Protogen. I haven't entirely figured out just yet how I'm going to get the artwork from the side panels onto the Protogen head, whether that's going to be something I'm going to have to design and send to manufacturer, or if I might solder it live on stream. I haven't figured that out yet, or maybe, you know, get the boards figured out and kind of go from there. I don't know. There's still a lot to figure out at this time. I understand a bit more, by the way. I was just letting you know. You seem to go into IRL cam. It's like switches to cam mic. I think, don't know if it's how you want it. What's the part number of that board? Oh, so it's not using the microphone of the webcam, but it is in fact switching. It's using the lavalier mic. So yeah, it's using this one, which I have below my face. That is in fact intentional. Which, yeah, it's working good. It drives me nuts because sometimes when OBS updates, it forgets the hardware address for this microphone, and I'll start talking and no one will hear me because it's not selected. And I'm like, why? Why must you break yourself? Oh yeah, one other thing that's a part of this, which I'm hoping I'll be able to incorporate as well, which again, haven't figured it out yet. We're not quite there yet, but the code example I have that was provided by the other Protogen maker that already has the predefined side panel artwork that I'm going to try to reuse because they made it publicly available, also includes a microphone to make the mouth move. There's a mouth animation. So I'm going to see if I can incorporate that into this, which means we'll have control over the expressions our eyeballs are making and still have the mouth movement from the microphone that's embedded. But my very primary goal is to get the controller and the expressions together. Oh, and the mic. That is everything I want to be in the initial head build. Will there be a revision? Will I continue to build on it? It's probably not going to be my next project after I actually build it. Like, I'll probably pivot to do something else, but I don't foresee myself being totally done with this. I definitely foresee myself spending more time in learning different things about the microcontrollers, and then maybe revisiting, making some changes, maybe incorporating something new. Right now, this is all very incredibly new territory on making something that's, well, unique to me, and I want to see it to the end. And then if something else comes out of it or I want to make some changes, well, then I will. That's the beauty about a project like this, is that I can drive the bus. I could drive the bus as I see fit. And where I'm hoping there will be a little room on the board when I'm done, because if I do want to add additional stuff, then I can. But I don't know. We'll see. But it's very, very, very large in the space of a project, but I'm here for it. I'm figuring out the separate pieces. I've got a box. There's no picture on the box, and there's also no picture on the pieces. I'm trying to figure out how to put the puzzle together. That's really the best way I could describe what I'm attempting to accomplish. But that puts us into the position of this nightmare that we're looking at. So the reason we're working with just something as simple as a blinking example is because it allows me to understand, well, work through to understand the core principles of what I need to be able to just draw simply a menu. I don't really care right now what the menu says or what necessarily the menu does. I just need to make sure that I can understand the concept of how to draw it, how to interact with it, and then how to be able to take that input and do something with it. Once I have all that figured out, it doesn't matter what the example has. Because then I can mold it to fit the Protogen project, which is what we're looking to do. Which I am super stoked, because to have not only one working example but two is super exciting, because I did want to have a submenu and I have working code for that. It feels a little bit like I'm kind of building my parachute, but I've already jumped out of the plane. But that's okay. It's that big tunnel from Portal 2. It's going to take a while before we find the bottom. So yeah, all right, I'm gonna nerd out a little bit here about the constructors, because I can tell you for a fact this was a nightmare to put together. We include our menu, which is fine. We have our LED, which is fine. This is where stuff gets a little squishy. We have to define what I don't know if I necessarily want to say should be obvious, but the quick example I put on in the server that just said Protogen Face Manager, quote unquote, did not require near any of these. Because of this library that's called Arduino menu, which is just shorthanded to just menu, has the ability to be incredibly flexible. That means you have to tell the constructor, which is making the object, every little detail that wasn't flat out expressed in the first way I found to do it. It's not a bad thing, it's just, it's heavily involved. So we have the size of our display. It's 128 pixels by 64, right? That's the width and the height. Our offsets, which we're not offsetting, just using the whole display as it is. The size of our font in the x-axis and the y-axis. So that's how wide and how tall the font's going to be on the display. We also have to declare which font we're using, but that's further down. You'll see that in a little bit here. And then we have to make our screen object. This library, the U8G2, is completely independent than what makes the menu, which is the menu library. Because this U8G2 is required because this menu object, like these libraries depend on each other, is what I'm trying to say. You can't have this without this because this is dependent on this being present. This allows you to interact with the display, and then this is an item that leans on that fact that you have it included. So then down here, we have this line that's called the constructor. So then what we have to do is tell the code everything about our display. And I mean absolutely everything. That's where my hang up came in. Because that's the protocol, right? Or that's it's the library. This is the specific screen I am using, the SH1106. You have to look up your board and which of these it's using, because if I were to pull up the wiki real quick, you will find there are many different generic no-name screens, and they have different names. That's required. If you don't have the right one, you don't get the pretty picture. We then have our screen size. It's not branded. And then I quickly switched this earlier, this one. This one means to run it in a more memory efficient mode. Now, if I wanted to run the screen refresh quicker, but not do a full size buffer, I could do, instead of quarters, I can do, I think thirds. It's thirds or half. I think maybe it's thirds, because instead of a 1, I could do a 2. And a 2 essentially means twice as fast. So 100 instead of 128, it would be that number times 2. 28 times 2 is 256 bytes of space, which means that you have to refresh half less often. And then we have to tell it the way we're connecting to the display, which we are using the hardware I2C protocol, which is how we're going to be able, I know that's how we're going to use that little connector on the side of the production board, is because that header is for the I2C protocol. I've also called it the I2C. It's supposed to be a squared, it's not supposed to be called a 2. Again, I've heard it both ways in some of these examples. And then you name your object. So I just called mine fruitface underscore display, because at the end of the day, this is what it's going to be. It's going to be the display that shows which face we're making on the inside. And then we're not done. We have more we still have to pass. Inside of the display object, we then have to define which orientation the screen is sitting relative to us. The R0 indicates that there is no rotation at all. And then there's several other rotations that can flip or rotate to the right, rotate to the left, or maybe rotate and flip, because the display could potentially be mounted upside down. So if, for example, you were not sure which direction was up on your specific display, there's no need to panic, because if you did mount it without checking, you can just flip the picture in the software. And that's what we'd be doing here. And then we're not interacting with an 8x8 keypad, so we are declaring none. And then these, I was a little confused as to what these were, and then I was able to figure out that that is the source clock and the SDA, which is the data pins. Those are optional. You're not required to pass these, and it did work without them, but I figured I'd add them because I'm not entirely sure if it'll be optional with the other board I'm using. We'll see. And then these are some timer values because we're going to be blinking an LED on and off. And then this is the thing that I was hung up on for a couple of hours. This little nightmare right here. A couple things about this little nightmare is that it's a constant. It doesn't change during the course of the running of the software, which is why it starts with CONST, because it's constant. It doesn't change, right? And even though it's a black and white display, I have to pass the color definitions, which turns on and off these different things that make up the background color, the foreground color, the value color, the unit color, the cursor color, and the title color. It's all black and white, folks. But if you don't pass these, you will get nothing on the display. It doesn't show anything. Now, if you really want to make your body hurt, mem mode indicates that this is going to be written to an area of memory that can't be changed during the execution of the code. And I tried to make a constant and didn't have this 6. I had mentioned this in the server. That's the 6 I was missing right there. That indicates that there's exactly 6 elements. 1, 2, 3, 4, 5, 6. Count them, 6. If that's missing, then you can't use mem mode. So I thought, oh, okay, well, if mem mode is literally, as it's stated in the error, is incompatible with the hardware, because that's what it said, I'm like, I'll just take that out and leave the rest of the definitions. No, don't do that. You're going to hurt yourself. I caused myself all kinds of grief because instead of being able to read what was under the highlighted text in the menu, it turned it into broken gibberish. You couldn't read what you had selected, which is counterintuitive in a menu. So I found out that because it's constant, you have to tell it how large the constant is because it can't change. And then from there, it was fine. This line was able to stay. That hung me up so bad. Out to dry. You know, I was out with the towels. And just waiting, hoping, praying that I'd be able to figure out what I was missing. And turns out it was that. So I put that back, I added that, and then the example worked. Now, as I had mentioned, we're manually making a menu, so now we're going to get to the part of the actual menu. This is something I'm going to need to dig a little deeper into. But for this particular example, we have fields that we are able to modify on the fly using the menu, which is why these are declared as fields. In the other example that I'm going to show you in a little while, you're going to see they're called something slightly different because you're able to do different things with those. And then we have to give it the name of the variable, so it's called time on and time off. We saw that up top because they have some default values. And then what's going to be printed on the display, so it'll be the words on and off. And then between, is that between or after? Let's take a look at the display. Or actually, I don't even need to take a look down here. Yeah, if we look down here, you can see it. So it'll be the word on, the number, and then MS for milliseconds. Howdy, Mr. Green. Welcome on in. And then we have some other constructor stuff, which I'm going to be honest, I don't know what they do. I just know that they're required or it doesn't run. And then we have these right here, which allow us to do two things. That allows us to set the lowest number that this menu option can be and the largest number this menu option can be. And then these two are the increments on how we can jump higher or lower. So we could jump in increments of 10 or increments of 1 without having to actually type it on the keyboard. And then the same thing for the off option. There is no menu to go back to, but this example did include an exit. And I'll show you that. The display shuts off if you use it, but you can get back in. Obviously, in a production example, like when it's going to be installed in the head, we don't want to be able to exit out of the main menu and then turn our face off. That would be bad. We don't want that. But that's okay. Knowing is half the battle. Okay, so then from there, we have to define how many levels our menu can go down into. Since this is a very basic example, there's only one level of the menu. So I don't have another menu shoved inside of that menu that would allow me to go to a quote-unquote another level. The other example on our right, we have over here, is a 2-layer deep menu. Which you're going to see, it'll say 2, and then we'll look at the menus. And then from there, we have to declare the next part that got me hung up in fantastic fashion. Or no, not the inputs, it's the other one. Since this library is incredibly flexible on what we can use to move through the menu, we then have to declare what things are going to be able to modify it. Or excuse me, inputs to it. So inputs are how we interact with the menu. In this case, we're using keyboard and mouse, which is why we just see in and then the word cereal here and nothing else. That's just the little box that shows up above it. But we're going to end up using different stuff when we actually put it into production. The part below it is you'll see many failed attempts here. Is the outputs. The output is where we slap a bunch of values together to make this actually work. So we have to declare it that it's an output, and we just named the variable out. We pass it how many menus deep this menu is capable of going, which in this case is 1. This is only 1 layer. And then we indicate that it's an out menu going out a U8G2 display. Remember how I mentioned earlier up that the menu library leans on the U8G2 library? So this is calling the library, so it's calling the book inside of the menu, volume, I guess I can call it. And then it opens it up, and then it goes, oh, you need to use the U8G2 library, which is not in this book, go to the other book. And then grabs that book off the shelf and says, okay, now if I look at both of these at the same time, I can figure out what I'm up to. We then build out the menu. So we pass it the Protogen face display. And funny enough, I would have thought that would have been enough to make this object by just giving it the display object. No, you don't. You need more. You need so much more. We then have to pass the menu the colors we're going to use, which is that big mosh of 1s and 0s I showed you further up. We have to pass the font of the x-axis, the y-axis, offsets, which we don't have any, they're all 0s. 2 additional variables that I don't remember what they do. And then we pass the width, the height, and then the font width and height. So the size of the display and then how large the actual letters are that are going to be on the display. And then there's a comma. We have the word none, which is just required when you're making this menu out. And then we also have serial out. The beauty of this being an incredibly flexible menu library is that we can take the menu we're generating and send it multiple places. I can have it appear on that tiny display and at the same time make it appear down here into the terminal window. If one of these is unavailable, well then I could still see the menu on the other thing. So if I unplug the display over there, I can still interact with it down here. It's all the same. But that gives you flexibility. And then we pass it the other informations to give us, what does this constructor do? I read about what is this? This is the main menu, ID menu, max depth in and out. Oh, okay, so this is what makes the actual menu object then. So we pass it the navigation, the main menu, as we had defined it, all the different options, how deep, so we're only one level deep, and then our inputs and outputs that we're going to use to interact with the menu or send out the menu. You need both of them to be able to make the thing. We do all that setup, and then we finally get to the setup section of the code. So all of that happens before setup happens. Setup is code you run only once during the application, or the run of the application, the program, and then we hit the loop that's down below, which you'll notice there's not a lot in the loop, because there's so much heavy lifting that's being done by the library. So we set our serial monitor to the mode that this board supports, which is 9600 baud. We wait for the serial monitor excuse me, we wait for the serial monitor to become available. So if I wanted to interact with this menu without the USB connected to the computer and there was no serial, this code would never finish running. It would never finish startup because it's waiting. So you gotta be careful. This is good if you want to be able to see these prompts, because sometimes the code starts so fast these just whiz by and you can't read them. This prevents that from happening. And then we have a couple other things we have to do to the display. The display on the back, it's printed on the back of the PCB, the actual board itself. It's a memory address that it's going to be used to work with the I2C. It's the I2C address, which makes up the hardware. So if you're looking to send a letter to the display, this is the address of the plot of land that the house is sitting on. And that just so happens to be 0x3c. Now, the *2, to be honest, I don't fully remember what that does, but the actual memory address of the display is this part. This is just a part of the constructor that sets this address value. And then from there, we have the address. We then have to initialize the display like I forgot to do with the controller, as I've been wandering through that. And then we set our font. We could change the way the pretty words appear on the display by modifying which font we use. And that's done right here. We finish our setup. Now, quickly, this is a void function. It doesn't return anything, that's wedged between the setup and the main loop. Normally I wouldn't put these here, but this is where it was in the example, and frankly I didn't move it. So this is outside of the main loop, and it's outside of this setup. So this code would normally be either up here or down here underneath the loop, but it just so happens to be wedged between the two, which is legal in the way that it compiles. You know, it runs, but it makes it a little difficult to read if you didn't notice that that's the ending of the setup. And this is just what does the quick little bit of math that figures out how quickly to blink our LED, which again, I'm going to show you that. We then go into our loop, and then we update the loop by calling on our blink function, which is right there, and pass it the amount of time that the LED will be on and the amount of time the LED will be off. Now, we've blinked many of LEDs on this channel before, but we haven't done before is control that using a menu. This is where the menu comes in. So we have a loop. Or excuse me, before the loop we gather input for our menu. So that's going to be our keyboard presses. And then if it's changed, if it hasn't changed, we don't refresh the screen. We don't change what's on the screen. So only if there's something different, then we call first page, and then we update the output chunk by chunk, because remember, we're not doing all of it at once, while there's another chunk to draw. So we just snap off the display from memory, throw it onto the hardware, and then snap off the next section and throw it on there, and just keep cycling and draw line by line by line until we have the whole picture. And then as you continue to interact with the keyboard, it then goes through the loop again, and then keeps drawing as it goes from line to line. To be honest, when I initially planned on drawing pretty pictures, I was figuring I could just use something simple, like writing some static text and then passing another quote-unquote static text that would just hold a variable and then just change what was typed in there by passing it the sensor data. So the way I planned on doing this has changed drastically, because I understood after doing some research that's not the way you handle one of these. You don't use it that way. And even though I probably could have gotten it to work that way after spending enough time and banging my head on my keyboard, it makes a lot more sense to do it the way that's considered best practice. And drawing a menu and allowing the menu to be responsible for what shows up on the display, where the cursor sits, all of those things that you would kind of hope are somewhat automated to be handled by the actual code itself and not having to actually type it. That's why we pivoted. We learned, right? And that's what we do. So where does that leave us? So that leaves us with the first example, covered from top to bottom. Now let me show you what this actually looks like in action. I'm going to show it to you first in the serial monitor. So, as I had mentioned before, the menu is currently being drawn in two places. It's being drawn down here, where we're looking at it, and it's also on the physical display that's sitting on the workbench. So, as it's mentioned, and now I didn't declare any of this, it's just what's built into the library. To be able to move around the menu, you use the plus, the minus, the star, and the / to control what's happening on the display. Since we're using just the keyboard right now, that's fine. That's going to change, but we're just not tonight. I have bored you all enough, and frankly I need more time. So to interact with this menu, there's this little caret, which is the cursor. I wonder if I can. I'm debating if there's a way I can make this a little bigger. That's a good question. I mean, I could do that, which isn't quite what I want to do, but that's all right. I'm just gonna do a quick restart of the code so we can see everything from beginning to finish. So there, we're using menu version 4, and then it says right here, use these keys to control the navigation of the menu. And then it draws the menu, right? So then for me to interact with this, I'm going to type in this box up here. So I want to go down a menu option. So I'm going to click the plus symbol and hit enter. You're then going to see it redraw the menu, and now the caret is sitting next to the word off. If I want to modify the amount of time that we're blinking off, I will then type the star, hit enter, and then the symbol changes from there being a space to a colon between the words off and the value, and now I can type in here. Actually, I could do a couple of things. I could hit the plus symbol and hit enter, which will change it to 100, and I could just keep doing that and changing in increments of 10. Or I could just type a value, say 300, and immediately modify that. Now, you'll notice something, that when I did that, the colon disappeared when I typed my value. I am no longer modifying the off variable. So then I could just hit the minus symbol to go back up, and now I'm on the on menu option. And I can hit star, enter, modify it, and now I want to be on for 500 milliseconds. Hit enter, and now it's modified. Now, if I go to the third menu option and work my way down here and hit the star and hit enter, the display on the bench is now off. There's nothing on it right now. And if I hit it again, star enter, the display comes back on. I'm just double checking over my shoulder to make sure that's true. You're going to get to see it on that side as well. But I just want to show you, this is what's happening in the terminal side. And that's what I'm typing in the little box. So why does any of this matter is because, frankly, if this menu works, then doing all that stuff in the code before is what got us to this point. Okay, so now I'm going to do a little bit of handiwork here and put us into, do I want to turn on the overhead? Maybe not. Let me see here. So maybe I do. Hang on, let me turn on the overhead. The trouble is I'm trying to make it so this is somewhat visible. All right, hang on, let me zoom the camera out a smidge. Because I want to be able to show you the LED, right? So I'm talking about this LED that's blinking away. I'm talking about that right there, that tiny little red LED. That's what's been blinking on and off. That's what we're controlling right now using our menu, right? So I'm going to do the same thing, right? Now you're going to see that there's a little flickering. I'm looking directly at it and my eyeballs don't refresh at the same rate as the camera, so I don't visually see the flickering, but that's what you'll pick up on your camera when you're refreshing this in chunks instead of doing the whole register at once. Now granted, I'm gonna be honest with you, it still kind of flickers when you do the full screen at once, but not as much on camera. So with nothing up my sleeve, I'm gonna hit the plus symbol and that's gonna take me back up a menu option. I'm gonna hit the star, which puts the tiny colon in there. Put that back in frame, little colons in there. And now I can type 200, and then as soon as I hit enter, it updated. Now it says 200 on the display. I can click plus to go down, and then I can do the same thing. I'm going to click the star, click enter, and then from there, I'll type 10. Now we're off for 10 milliseconds, we're on for 200, which means this is rapidly blinking on and off so fast it's actually hard to see. It's like it's faintly flickering. So if we want to make that look a little more apparent, let's change the off to, let's do 100 milliseconds off, and then let's go back up one, and then hit star, and then change this to 800 milliseconds on. Actually, that'd be a really slow blink if I do that. Well, I mean, proof that it's gonna be a really slow blink. It's a slow blink, right? But we want to minimize the amount of time between on and off to go quickly. So if we do, was it like 90 milliseconds on and 100 milliseconds off? And now we're blinking really quickly. So that goes to show that that's what happens with the menu, right? And then as I had mentioned, and I of course promised, if I try to go into the back menu, there isn't one. So it just shuts off. But I could just hit the star key again, hit enter, and then our menu reappears. So that is the example of the blink menu. I'm going to show you the other example that does include the submenus. So what I'm going to do is I'm going to show you the code side of that. We'll upload it, we'll look at it, and then you'll get to see that in action. Okay, so that takes that to town. And then we have the other example. So this is the other one. Now, both of these examples were provided from somewhere upon my research that were provided within the libraries. Like I know this one, for example, the link to it is, the GitHub is right here in the examples code. And this one I got directly off of the the GitHub for the library, which was great because it's very, very appreciated. To have something to work off of. Okay. I am not going to go over all the same stuff. I'm just going to point out what's different. So, a lot of this is going to largely be the same, give the way the menu structure is actually defined. So, all that's the same, all that's the same. We are playing with the LED, but we're not blinking it this time. We're going to just be able to turn the LED on or off. There will not be a blink. Now, you're going to see code in here about a rotary encoder, which is the little wheel. I'm not using that, but the example included it. And the other thing you're going to notice too is that there's a definition up here for a screen I am not using. I am not using the SSD 1306. So even though this is up here, you can ignore it because the way I reuse the code, it's here, but it's not being used. You can ignore all of this code right here about SPI because we're using an I2C screen, which is why you're going to see the wrong information here because we're not using it. I did not really have the time to scrub out the stuff we're not using, which is why I'm just going to gloss over it. And then let's see here. So then we hop down to here where I think that's actually the font we're using. If I quickly shoot it down here, because again, this was another example I pulled, so it's written slightly a little differently. If I go to the void setup. Yeah, okay, that is the actual font we're using. So this example is going to look a little different because we're using different words, a different font library. So this font, now in my example that I showed you first, we could have put the font up here in a define and then call it further down by its name. We just didn't do it that way. This is just another way to do the same thing. And then we're going to pass some variables here. The screen height and width will obviously be the same. This example did come with an offset on the Y. So instead of drawing it exactly where the code says, you're going to take it and then shuffle it 3 pixels up or down. I'm not actually sure which way the offset pushes it. Well, it's an offset on the Y, so Y goes up and down, X is left and right. So it's offset 3 units of some fashion here. And then this is exactly the same. This right here, because it's the same hardware, we're using it the same way, and more importantly, we're using it via I2C, because that's the way that it's wired. SPI is another way that we can interact with hardware, but this specific display doesn't support that mode. So if you're going to reuse something like this one provides an example to use I2C or SPI, which is great because this example is flexible, but it's a cause for frustration if you don't know the difference, because it does in fact matter. So yeah, that's the same. The color definitions are exactly the same, and funny enough, this right here is how I found my mistake, because the other example I was working off of didn't include the 6, but it did have the mem mode. So this is how I actually figured out my problem, by using this other example that did in fact work correctly. And sometimes if you have an example that doesn't work, just try to find one that does. Even if it doesn't do exactly what you want to do, you might be able to pick out the thing you need. And that's exactly what I did. No shame. Mine doesn't work. Let me look at another one and see if I can figure out why mine doesn't. And I didn't want to scrap that one completely. I was getting a little frustrated with it to the point I almost wanted to trash it and not even show you guys that. But there was learning involved. I figured it out so it works. But more importantly, I didn't fully give up on it because it does do something neat. And it does show you something that this example doesn't do. That one allows us to change values on the fly, while this one's going to allow us to just cycle through the menus and toggle something on or off, which is important and it's different. through the whole process of trying to learn this nightmare, is seeing the different ways that this stuff works. Okay, so we have some extra stuff here that complicates this. This is a call to the do alert, which I believe where is it? Yeah, it's this right here. So this is a call to a void function, or excuse me, it's not a void function, a function that returns whether to proceed or not, and whether the screen is idling, or if we should be showing some different text on the display. So this is an example of a function that's written that's out of the way, but it's called further up. Now again, I didn't need that in my example, and that's a little bit more complicated. And then we have some test information, and the big difference between what we had and where we are is the LED. We're not changing a blink rate, we're either just turning it on or off, simple as that. So the fact that we had a menu that was designed at having a numerical value, you're going to see is different than the other one. Now I'm going to quickly snap this on the other monitor here, just so I can show you side by side the menu section, because I do want to point out what's different here. So in the menu for toggling the LED on or off, which we're going to be able to do, our menu option is a value. It's not a field. They're different. A field had a value that we were able to modify, but a value in this use case is on or off. Can you do more? I'm probably sure, but as this example is written, and I have very surface level knowledge of this because I'm still very much learning it, that's at least a major distinction I saw right there. And then we have our self-test, which has the value of 0, 1, or 2. And then we have a couple of other sub-menus. This one's called choose, and then we can choose through the options. We then take our menu, pass it our sub-menu, which this is where things are written a little out of order, which is why this got a tad bit confusing. Yeah, that's not our main menu. This is a sub-menu called sub-menu. So this is a sub-menu that says the word sub-menu, that then contains just one option, which is just sub 1. This does nothing. It just shows you that it could be an option with another level, and a way to go back to the main menu. Some hours and minutes variables, and then a alt menu, which is just called menu. This is the time menu, and the ability to modify. See how they're fields, right? Field over there, field over here. We can modify the value of the hours or the minutes, but they're fields because you're modifying the numerical value. You're not turning something on or off. We then have some char variables, which are constant. I'm not entirely sure what those are for, but they're in here. And then this is the meat and potatoes that's hugely different, is the main menu. Now, our first example is just a single level menu. It's one level. You're on the level. You're standing on it, right? This one's got sub menus. So we see here that our main menu has option 1 and 2, which do nothing, right? It even says do nothing. And then under that is where we call the sub menus that we just looked at that are written further up in the code. So the time menu, the sub menu, the LED menu, and then we have some options here to modify the LED directly that are not inside of another lower level. Now, something that may be a tad confusing is that we have many sub-menu options, but the depth of it is only 2, because we have the main menu that we can look at here, which is this level, and then anytime we go into a sub-menu, at no point was there another menu wedged inside of this menu. So inside of the time menu is only stuff for modifying time-related items. The LED menu is only for LED stuff. If we shoved a menu inside of this menu, then the depth would go up to 3, but we're only at 2 levels deep, which is nice because I don't want to go any deeper than 2. I feel like that's enough complicatedness as it is. So then from there, we have a couple other just kind of dummy things that we have tossed in here, and then an exit, which allows us to get back out. All of our oh my god, words don't want to work. All of our menus are capable of going back to get out of them, even if they don't have that exit field, which is what I noticed because of the way that we use the keyboard. I could go back with the backslash, and I can go forward with the star symbol. I can go up and down with the plus or minus symbols. So that's your up, down, and then your backslash and your star is left and right to go into or back on a menu. You don't need to declare an exit. It's just nice if you want to be able to see that. And then from there, this stuff is the same. That's the same. We have some extra example code here that is just what happens when you go into those submenus. We then fire up the display. You're going to see the example begin for SPI, but we're not using it, so it effectively does nothing. And then exactly the same code for the menu. So we get our input. If something has changed, then we go through the pages. If nothing's changed, we do nothing, because this is nested inside of this if statement. The if starts here to here. So if we get our input and nothing's changed, this code does not run. And then this just delays 100 milliseconds just to simulate, quote unquote, doing something else in the meantime as we cycle through our menu. So I'm going to push that, and then I'm not going to bore you with the terminal view. We're just going to switch right to the display so you can actually see it in action. So I'm going to click the push button. We're going to wait a moment. Okay. So, this is the full menu. It's got 9 options in it, and you can already probably imagine, well, that little display is probably not tall enough to show all 9 options at once. And you'd be correct. We can have a menu that's longer than the display is in height, because when we scoot down another level, then one of those menu options will run off screen, and then we can go down to the next level. So we're gonna look at that next. Okay, so we now have our more complicated menu, and we'll notice that our LED is actually blinking right now, which is interesting. It's funny because the LED I saw was on or off, but there was that other thing in here for the other one, which is a little funky. So if I can orient this so that the wires aren't in the way, because the menu is really what we're here to see. frame so y'all can see it. All right, so then same rules as before. I can click the plus to go down, and then I can hit star to go into that menu. Now there's no additional level to that menu, so I'm not able to go into it. So I'm going to hit click plus to go down another level. Now, the time, we saw that we were able to modify an hour and a minute value. So to modify that, I'll hit star, hit enter, and then that puts us into modify mode. Now you can see here that it actually bumped us over a bit. And I think if I hit the plus symbol and hit enter, does it? It may not do anything. So if I do star, and then do say 5, time submenu. I got the colon right now. The plus doesn't do anything. What if I do a 2? Star again. Star jumped me to the next item. Interesting. So we're modified minutes. How did I skip over hours? Let's go back in again. So we're gonna do star. Star again. And then can I do like 8? Ah, there we go. Okay. So you gotta hit star twice. Weirdly enough, there's another level outside of that, which I'm not entirely sure why. So if I go back out again, I hit plus, and then plus again, doesn't appear to do anything. If I hit the backslash, I can exit out of that menu. Now, if I go too far back in this example, it just says the word suspended, so which I could just hit the back again to go back out to where I was. And I can click the plus to go down, which is where we have our first sub menu, and I can click star and enter, and that takes me into the next menu. So we have sub 1 and back. Now to go back, I could just hit the backslash and hit enter, which takes me out. Or I could arrow down to back and select it to also come back out at that level. So I was at level 2 and I'm back to level 1. I could scoot on down to the LED, which is currently set to on. If I want to modify that, I'll hit star, I'll hit enter, and I can't enter a value. It just switched it off. Now, that particular function must not be tied to this piece of hardware because it's still turned on. If this was tied correctly to the menu, that's what we would have saw. And I can hit star again and hit enter, and it switches the function back to quote unquote on. I could hit star to go down a level, which is funny. We have another LED which is on. What if we cycle that one? Is that one tied to something? Star, LED off. Nope, it's still on. That's exciting. Frankly, I'm not too concerned about that, just because of the very simple fact that this was just to really showcase the menu. I don't really care what it does, as long as it does something. And being able to see that there's multiple levels is fantastic. And then if we go into the choose last, we can then cycle. There's choose last, third, second. I could go back up with the minus symbol. I could select second. So I've chose second. I could go back in. I could choose third by hitting that, hitting star, and hitting enter. Now the choose value is set to third. There's the alert test. I actually didn't try this off stream. Actually, that must be that alert code. So let's go into alert. Alerts test, press select to continue, which in this case would be star. And that brought us back out. Now if I hit minus to go back, plus to go down, that doesn't actually do anything. I have to interact. Nope, okay, I can still back out with the backslash. So star to go, and then that brings me back out again. I don't know what the hex option was for. What does that do? Oh, I gotta modify the hex value. Alright. That's fun. Yeah, and then, I believe if I exited this level, I think it says suspend. It does. So, right now, that proves that the display is at least navigatable. And the next step is going to be getting that conversation to be had between this piece of hardware and this piece of hardware. So I certainly have my work cut out for me. There's a lot more to learn, because that small section of code where inputs are is the next massive mountain we're going to have to tackle. To be honest, maybe it won't be that bad. Maybe it'll be really bad. I haven't quite made up my mind on what that's going to look like next. So that's super exciting. I mean, I'm here for it either way. I really want to see this project come to a successful conclusion. But that's where we've come with screens. And over the course of me ranting about it for an hour and a half, I hope gives a little bit of context as to why I struggled with it so hard. It's I had to look at a lot of documentation to try to figure out, to make some kind of sense of what I was looking at. And I'm grateful that I've gotten some flavor of understanding, because not only can I talk about it, I really feel like I could take it and continue to move forward to the next steps on what we're going to do here, to make, something similar to what we're looking at, this Protogen, to be a reality. And I'm so stoked for it. My ranting aside, do we have any questions about the code, about anything I showed? Just out of curiosity. I'll break my shoulders there for a second. Because I do realize this is a lot. It was a lot for me too. But the fact that I love that emote. I love it a lot. I'm hoping, even if I did lose you along the way, that at least it does present that it's not possible to figure this out, but there is a lot of moving pieces in making something as simple as a touchscreen not a touchscreen, a display that's 1.1 inches in width. Tech is hard for you. Well, I can tell you, as the tech head, it ain't easy for me either when it comes to some of this stuff. Some things are more challenging than others. Hedgie, you do amazing art. And I don't. No, we don't do art. We do not do art here. Yeah, but yes, thank you very much. That was indeed on purpose and on brand. But you understand that the craziness that this little hedgehog in chat here does is completely off the wall. This guy, that one. If you're not following Hedgie already, you should go do that, because half of the more than half of my emotes, most of my emotes, actually I think on the channel they're all a set, makes fantastic art, and has made some very, very pretty things. Hedgie, are you still in the middle of doing a giveaway, or did you just finish that already? You've been bouncing around doing a couple different things. I don't recall off the top of my head, but by all means, go follow the little guy, little prickly little guy. He does some really cool stuff. He's got all of the energy and then some. You think I'm loud? Pictured both of us in the same room. Go watch one of his streams. You'll understand. Oh, my bad. I thought you were. I thought you were in the middle of doing one, which is why I wanted to ask. I guess not. Hobbit or Landon are not here for the no free art. No. I thought you had a legitimate giveaway going on. I am not indicating that you do art for free. We're not doing that. You're not doing that, because I'm on the same train as Hobbit and Landon. You're getting paid because you do good stuff. Maybe soon. All right, fair. Yeah, so the I would love to stop scratching my face, but my sensor won't let me. The I'm gonna tell you right now, that is not the face I wanted. That is not the face I wanted either. Come on, where is it? There it is. I am going to get these hands fixed, okay? I don't want my hands keep shoving into my face like that. It's very annoying. I've tried my best to ignore it, but it's very difficult to ignore. So yeah, well, when money allows, we're gonna fix that. Because you would think a sensor that's, you know, as old as this one is, I haven't owned it that long, but you would think because of the technology would have gotten cheaper. No, it hasn't. Not even into the slightest. It's still like $150 sensor. With time, you are correct. You are correct, dear Hedgie. As is most things. So that is the Toaster's rant for this evening. So with the next go around, I anticipate that we'll probably play some retro stuff. Even if I have something to show for Proot, I'll do a pause for the next stream. We'll play a game for next stream so I can rant a little less. So yeah, happy that. So for those of you who are here, who are new, I do this and I play games. If you want to see more of my madness, you can follow. If you want to do the thing, feel free to. This channel moves like trying to herd kittens. I'm in all the directions all at once, but it's a part of what I do, and I enjoy what I do. With that, then we are going to take a pivot here. Let me see who's on right now. See who would be a good person to go say hello to. Okay, I know where we're going. We're going to someone new. All right, I can type. Fantastic. So I have no idea who rated me into Soup Was Here, but they were fun to hang out with, so I would like us to go wander over and say hello. They are currently in the middle of doing art, just like our dear Hedgie does here. And I think that would be cool to go pop on in and see what they are up to. So with that, I will see you all for next Wednesday. Oh boy.